In this video, we're going to look at manipulation of formula, a key skill in algebra. So we'll normally be asked to write in something in terms of another letter. So if we write this equation in terms of b, what we want is the answer to look like b equals. So we saw something similar in simultaneous equations, one linear, one non-linear, where we had to write x is equal to or y is equal to. So this is kind of a follow on from that. So if we want b on its own here, the first thing we do, we bring across a minus c. And to get b on its own, we have to divide by 4a. So 3a plus c over 4a is equal to b. So this just involves adding, subtracting, multiplying, dividing. We also can have square roots and squares inside them, and cube roots and cubics inside them. So let's have a look at one of those. So if we look at this one, a is equal to b, the square root of b squared plus c squared. If we want this in terms of c, I'm just going to put the letter in a bracket like this, in terms of this letter. So we're going to square both sides. So we get a squared is equal to b squared plus c squared. So a squared minus b squared is equal to c squared. So the square root of a squared minus b squared is equal to c, and you may identify this as Pythagoras' theorem or a version of. So pause the video and try these two. First one in terms of c, second one in terms of b. Okay, so we want c in its own. So we're going to have a plus d is equal to b c squared. A plus d over b is equal to c squared. So c would have to be the square root of the whole fraction, a plus d over b. And you guys know this could be written, you don't have to write it like this, but when we have a square root of a fraction, it's the square root of the top over the square root of the bottom. So either one of these are fine. Next one. So we want b on its own. So if I cross multiply first, I'm going to get a plus ab is equal to 1 minus b. We want to try and isolate the b's, so bring them together. So ab plus b is equal to 1 minus a. So factor out your b, and you're going to get a plus 1 equals 1 minus a. So b is equal to 1 minus a over a plus 1. So again, pause the video and try these two. It shouldn't be too difficult. Okay, so we want to get rid of the square root. So we're going to have x, we're going to square both sides. X over y minus z is equal to x squared. At this point, I could divide both sides by x, but I'm going to just cross multiply to begin with. X is equal to x squared times y minus z. Now I'm going to divide by x. So I'm going to get 1 is equal to x times y minus z. So 1 is equal to xy minus xz. 1 plus xz is equal to xy. So y is equal to 1 plus xz over x, or 1 over x plus z. V squared is equal to u squared plus 2as. This is for you applied math students. So we want u, so v squared minus 2as is equal to u squared. So u is equal to the square root of v squared minus 2as. So again, pause the video, try these final two. So you want this one in terms of or. So we could multiply by 2, or we could bring the q over 2 across to the p. Well, let's multiply by 2 first. 2p is equal to q plus 2 root r. 2p minus q is equal to 2 root r. We want r on its own. So dividing by 2 will just get me back to what I should have done at the beginning with bringing the minus the q over 2 over, but we could write 2p minus q over 2 is equal to root r, and now I need to square both sides. So 2p minus q over 2 to be squared is equal to r. And we could multiply this out, or we could leave it alone, but we're going to get 4p squared minus 2pq twice, which is 4pq minus q squared over 4 is equal to r. You could divide the 4 into the first two terms and leave the q squared over 4, but that is perfectly fine. So the very final one now, manipulation of formula, r is equal to the cube root of ab. So to get rid of the cube root, I got to cube both sides. So r cubed is equal to not the square root, I'm cubing it, so it's equal to AB. So we want it in terms of A, so A is equal to R cubed over B.